Alright, you're welcome to the Mathematics Made Simple. This class is intended to help students to understand the very basic concept of mathematics. Of course, the name of this class is Maths Made Simple 247. And today we'll be learning a topic in mathematics which we refer to as differentiation. There are problems that we want to solve here because this class is actually a problem-solving class. But I think there is need for me to explain some very basic concepts on differentiation. And I think it will help you understand how to solve differentiation. Come with me to the class now. You're welcome. We're asked to find the derivative of the following function. You can see the function for yourself. There are about four functions there which we want to find the derivative. But here and now, right here, I want to put you through these very basic principles of differentiation. They are called rules, okay? They are called rules. Now, rule number one, if y is equal to if y is equal to x raised to the power n, then the derivative of x will be, the derivative of y, sorry, will be equal to nx raised to the power n minus 1. Now, example is this. Let's say y is equal to x raised to the power 5. If x is raised to the power 5, then the derivative of y will be equal to 5x raised to the power 5 minus 1, which will leave you with what? 5x raised to the power 4. Okay? 5x raised to the power 4. I hope my camera can capture this clearly. Now let's go to rule number 2. Rule number 2 says if y is equal to kx raised to the power n, where k is the constant there, where k is the constant, then the derivative of y will be equal to kn x raised to, that is n coming to multiply k, x raised to the power n minus 1. Now let's take example now. Example is this. If y is equal to, let me use this, y is equal to 5x raised to the power 3. Okay, the derivative of y will be equal to 5 multiplied by 3, x raised to the power 3 minus 1. Okay, minus 1. Now, that means that the derivative of y is equal to 15x raised to the power 2. Okay, I hope you can go with these rules that I'm stating here now. Very quickly, I want to take this off so that I can come up with rule number 3. Now, the rule number 3 says if y is equal to, let me state it clearly so that you don't mix it up. If y is equal to k, all right, where k is exactly a constant, then the derivative of y is equal to 0. Let me give you an example. Suppose we say y is equal to 7. It means that the derivative of 7 of y will be equal to 0 because 7 is a constant. I hope you're clear with these very three basic rules I've stated here. With this, let us go right into the class and solve our question. Now let's go. I hope you capture this. I've given you time. Please take these rules down because I'm referring to those rules. Let's go. Let's go with number 1. Now, number 1, in 30 seconds, let's see the solution to this. The derivative of y, as far as this function is concerned, will be what? 3 multiplied by 5 will give you what? 15. And so we take away what? 1 from 3, and that will give you what? With 2. Plus 1 multiplied by 4 will give you what? 4. And then you have x raised to the power 1 minus 1. Plus the derivative of constant is 0. Hence, therefore, our derivative of y will be 15 x raised to the power 2. 1 minus 1 is 0. X raised to the power 0 is 1. 1 multiplied by 4 will give you 4. So the derivative of this very function here is 15x squared plus 4. Let us go very quickly to question number 2. Alright? If you permit me again, for purpose of space, I want to take this off. If you have taken it, you can always play back. And please, when you're watching my video, please, you will see the full there. You can just tap on that full to have the screen to yourself so that I can view this solution very well, and you can view the explanation to what we're doing very well. Let's go to question number 2, and this is where students have some kind of issues. They go ahead and make unnecessary expansion. Now, you don't need to do all that. Please join me as I solve this problem with you now. You're told here that y is equal to 2x plus 1, all right, and it's raised to the power 3. All right, I will just say to solve this problem, let y be equal to u raised to the power 3, where u is equal to 2x plus 1. So I'm substituting 2x plus 1 with what? U. So here and right here, let's differentiate y with respect to u. If we do that, you are going to have 3u raised to the power 2. I hope you know that learning from the basics, from the rules of differentiation, that will be 3u raised to the power 2. Okay, differentiating u with respect to x, that will give us what? 2. Remember that this is a constant and it will be 0. How did we get this? Of course, there's a power here. X is raised to power 1. 1 multiplied by 2 will give you 2. 1 minus 1 is 0. X is power 0 is 1 multiplied by 2. That will give you what? 2. Here and now, what are we looking for here? We want to find the derivative of y. Therefore, the derivative of y, which is dy dx, will be what? 3u raised to power, or what do I do here? Let me help you so that you can always play back. We multiply the functions together, that is dy du multiplied by du, multiplied by what? Du dx. Okay, it is still the same thing as dy dx. Why did I bring this together? In order to multiply 3u raised to power 2 multiplied by what? 2. And that will quickly give us 6u raised to the power 2. What is u representing here? It's representing 2x plus 1 raised to the power what? 2. That is the derivative of y equal to 2x plus 1 raised to the power 3. Let me give you some time. Take this down, look at it again, play back and look at what you can solve any function at all. Having done that, very quickly I want to go to question. With time, I will look at these two. But I tell you, I can leave this for you to do. It's just the very basic principles of how you solve this. If you can solve this, you can actually solve this. If you can solve this, you can solve this. But the challenge you are having there is you are not asking me, why do I have a fraction there? So I'm going to leave this and solve this, and then leave you to solve this and give me the answer. Leave the answer with me in the comment section. Very quickly, I'm taking this off. Let's take this off. Okay? Let's take this off. And let us look at y equal to 5x squared plus 3 raised to the power 2 over 3. And I say here, let y be equal to, I want to now represent, do I represent it with u? Okay, let me go ahead and say, let it be equal to u raised to the power 2 all over 3. Where, of course, you know that u is equal to 5x squared plus 3. Now, the derivative of y here, dy du, will be equal to 2 over 3 u raised to the power 1 all over 3. Alright, raised to the power minus 1 over 3. Let me explain that. You are now saying 2 over 3 minus 1. And of course, the LCM is what? 3. Okay? 3 LCM here is, the LCM here is 3. So 3 and 3 is what? 1. 1 multiplied by 2 give you 2 minus, you know that the denominator here will be 1. 1 in 3 is 3. 3 multiplied by 1, that will give you what? 3. So 2 minus 3 is equal to what? 1. Alright? That is why your answer is minus 1 all over 3. So that's why I have 1 over 3. I hope I've explained that. And so your your u here, the derivative of u with respect to x is equal to 10x. It's equal to 10x, meaning that the derivative of 3, which is a constant, is 0. Hence, if we now take what is dy dx, very quickly, I'll just take 2 all over 3, 2 all over 3, alright, u raised to the power, let me write it together, 2 all over 3u raised to the power 1 over 3. Why am I writing it like that? There's a law in indices that says a raised to the power minus 1 is the same thing as 1 all over a. Alright? So since I have a negative index, I'm writing it 1 all over u raised to the power 1 over 3. I hope I've explained that. Multiplied by what? 10x. So our final answer here will be 20x all over 3, open bracket, 5x raised to the power 2 plus what? 3 raised to the power 1 over 3. I want to leave it there as my final answer. And I want to encourage you, please go through this. If you have any question, you can always post your question to me in the comment section. Thank you very much for this time you spent with me. I'll see you in my next class.